welcome to this session. In this session we are going to discuss some other applications of XML. Already we have discussed certain applications in XML. The remaining applications we are going to discuss in this session. First we will start with SMIL, Synchronized Multimedia Integration Language. It is a most powerful XML based language which is used to integrate different kinds of data or different kinds of information in different format into XML, and SMIL is used to store multimedia related data and integrate multimedia data, and then SMIL is enabling interactive session, through some APIs or through the authoring tool in the audio visual presentation. So we are able to give some input during the presentation, and then based on the given input, some of the content may be skipped or some of the content may be played and so on. So interactive mode is enabled by SMIL, and then SMIL is used for multimedia presentation, which will integrate streaming video, audio along with images and text. And then the next point is, it is easy to learn. SMIL is easy to learn because its syntax most looks like HTML syntax, so that we are easily able to learn SMIL. And then SMIL can be created. I mean, you can create or you can make use of SMIL in a simple text editor, right? Simple text editor. You are able to write SMIL program using simple text editors. And then it is designed to combine text, graphics, video, audio in real time. It means we can connect text receiving unit, graphics receiving unit. Let us take some program is playing on the stage. You are going to get video content and audio content, some graphical effects also, and textual representation. Along with the textual representation, you want to combine. SMIL is designed to combine all those things in real time. That is very important. We are able to get video, audio data in real time. At the same time, graphical and textual information embedded into audio and video information can be grouped together. And then used to schedule. SMIL is used to schedule, synchronize and organize the presentation. As I said previously, the presentation can comprises multimedia data. In such case, we can schedule at what time we need to play this video, at what time we need to display this kind of text, and so on. So several formats, several contents are available that should be synchronized and organized. Then only we are able to schedule and play what is needed, where it is needed, when it is needed, how it is to be used, These kind of informations can be done by using SMIL. And then SMIL documents are comply with XML 1.0 version. So it is complied with XML 1.0 version, and it uses its own DTD file. SMIL uses, as like the other applications, SMIL uses its own DTD file. So its elements and attributes, SMIL, all elements and its attributes all are available in the separate DTD file. That DTD file is to be included into your program by means of doc type tag. Doc type prefix used for SMIL, and then public or system, and where, in which location we are having the DTD file, that location should be provided. URL used for fetching DTD file. And then the layout which is followed by SMIL is CSS2 model. Basic layout supported by SMIL is following CSS2 level 2 syntax followed here, so that you know that most of the browser giving support for CSS2 so that the content may be easily, SMIL content may easily be recognized by the browser. The project started in December 1995 and released in November 1997. SMIL project is started in December 1995 and then was released in November 1997. See, SMIL comprises multimedia data, so we need player, video, audio, content play, we need player. What all the players are supported by SMIL? Apple QuickTime 4.1 minimum configuration. Nowadays we can have more number of, more version of the same players available, and also some new players may included in the list. That may not be standard one. I am giving only the standard players which provide support for SMIL. Apple QuickTime, Internet Explorer, Vertex GRE NS player, Real player. So these players provide support for SMIL. The standard SMIL document structure, as I said previously, it looks like a HTML. Starting tag is SMIL and then head tag. Within the head tag, we can give the metadata informations and then open the body information, and content of the presentation needs to be there. Content of the presentation, we need to place it in the body tag and close the SMIL. This is the standard structure followed in the SMIL document. And what all the media elements are supported by SMIL listed here: animation, audio, IMG, text stream, video. As I said previously, SMIL is providing support for multimedia data integration and playing and manipulation and so on. In order to provide support for that media elements, animation tag is added. Animation tag is used to add animation. Moving pictures, right? Moving pictures called as animation. That kind of animations can be included by means of animation tag. Already created animation included by using this tag. Each frame is created individually. Independently, the frames are created and all frames are grouped together. When we are grouping the frames, we need to follow the proper sequential order along with the timing control. Because that is very important for playing animation. If you are giving very less time, then we may not get the effect what we expect. That may not be derived in the presentation. So that animation tag is used to include animations data, and then as well as you can group more than one frames together in the sequential order along with the timing control. And then audio tag inserts audio file. The supported audio files are WAV file, MIDI file and real audio files. And then next tag is IMG tag. It is used to add images to the document. GIF, PNG, JPEG images can be added. And then you can add text informations formatted using CSS. You can add a text information formatted using CSS into the text tag. Text stream, scrolling text. The scrolling marquee or scrolling text, if you want to add to the document, then text stream is used. That scrolling message or scrolling text is to be formatted using CSS. As I said, because SMIL provides support for CSS. So CSS files easily adopted and handled by SMIL, so that we need to format the scrolling text using CSS. And then video file. It is used to add video files. That video file should be created in MPEG, Real Movie, QuickTime Movie video formats. These are all the video formats supported by SMIL. And then next one, XSIL. Next we are going to see what is the use of XML in scientific applications. There are one language is available, Extensible Scientific Interchange Language, XSIL, which is derived from XML, and it is used for scientific applications. See, scientific applications, several parameters available, timing related activities are available, several tables, clock table like several tables available, and array of elements or array of values are available. all those values or all those elements are handled by using XSIL. XSIL is providing the basic structure for organizing scientific data together with the extensibility, because today requirements may not be sufficient in future, so that future requirements may be changed than the current requirement, so that when we are combining or when we are creating XSIL file, it provides extensibility. See, XSIL itself provides extensibility, then only we are able to use the extensibility. So that XSIL obviously provides extensive nature along with structuring the scientific data, for example, table, array, parameters and time, etc. And then extension is possible in two areas. Extension is possible in two areas. One is XML side extension and then JavaScript, because by using JavaScript and Java program, we are rendering the code or we are using the XSIL, so that Java object side extension is possible and XML side extension is possible. And XSIL provides or offers modular programming. What is modular programming? We can divide the entire program into smaller programs. For each and every program, we can create a module. Module is an independent unit, right? Module is an independent unit. Anyhow, we require input and output, right? Input we need to get it from other modules, and the current module may produce output to the other module. I am talking not about that. I am talking only the internal architecture or internal cohesive nature or internal nature of modular programming. I am talking about module is an independent unit internally. And then self-sufficient module. Module is self-sufficient. In such a way, we need to create a module. It accepts input from other modules and it provides output to the other modules. Modular programming is possible here in XSIL. And then extensible viewing platform is provided. Viewing platform. See, obviously, it provides an offer to structuring scientific elements. But how can we identify all scientific elements are available? When we are rendering or viewing, then only we are able to identify whether that scientific applications includes all components necessary to reach the goal of or reach the requirements of the current application. That we can check only when we are viewing. In order to viewing, it provides an extensible platform called XLOOK. And then for XSIL, a separate DTD is defined. In that DTD, all basic structures which is necessary, right? All basic structures which is necessary to form or to construct the scientific data, all those elements are grouped together along with their syntax in DTD file. So XSIL is using its own DTD, and then the table is modeled based on the relational table. Already we have relational model or relational table based on the existing RDBMS like that. The relational table, the XSIL table is constructed or table is formatted, and then it takes a record structure. In the relational table record structure, we are storing the information. In the same record structure, in XSIL also we are storing the information. All records are similar structure, that you know. When you take a particular table, all records follow same structure. Similarly, XSIL is also following similar structure. And then array is for low-level data. Array is used for storing low-level data such as images, time series, spectra, right? Images, time series, spectra. In order to store these kind of data, the array is used here in XSIL. XSIL uses a pure Java application. Already I told that XSIL is based on pure Java application, because Java characteristics available there. So that obviously we are getting portability. It is the features of Java, right? Feature of Java, portability. We are easily able to port our program or move our program from one location to another location, or one platform to another platform, one operating system to another operating system. That kinds of portability we are getting because of pure Java application used in XSIL. And then programming efficiency is also included. This is also a feature of Java. Programming efficiency also included there in XSIL. And then XSIL is providing XML model for data transfer. We can store the data in XML and we can transfer the data using XML model, and then where we are using that model, from the XML model we are going to extract the data. That XML model is being adopted in gravitational wave and astronomical communities. Gravitational wave and astronomical communities, they are using the XML model. Because of that nature, XML model is internally or provided by XSIL, and then XSIL is used as a documentation mechanism for collecting data and resulting from the experiments and simulations. See, it is a scientific application. This particular language is used for storing the scientific application results. So that the experiment results or simulated results are collected together and it is available in the document format. The document is created using XSIL, and then XSIL provides support for parameters. XSIL provides support for parameters, and it also defines structures, and it gives file names and other informations. By using these parameters, structures, file names and other informations, we can kept scientific record, a complete scientific record in the XSIL document. And then it provides a natural mapping between. It provides a natural mapping, no artificial mapping. It is a natural mapping between elements. It means XSIL mainly focusing on real world entities. Real world, what we are seeing in the real world, based on that it creates a XSIL, it creates a document. So that it provides a direct mapping or natural mapping between elements of XSIL language and object model. Object model which we want to translate, into. So that obviously the translation done by the parser. So based on that parsing nature and real-time entity, the XSIL have been developed so that it provides natural mapping between the elements of the XSIL and object model. And then tags of XSIL: comment, param, time, table, array, URL, streams. These are all the tags available for the creation of XSIL. XSIL, that is used as a root tag. It is the base container for object model. We are creating all contents in the form of object model, so that XSIL is used as a base container for the object model. And then comment. If you want to supply any comment to any of the document, that may be supplied by using comment tag. And then parameter. As I said previously, we are going to create XSIL document for scientific application. So that parameter, if you want to store the value for the parameter, if you want to store, then we can pass all parameters using this tag. It contains two pair, a pair value contain, name and value pair contain in the parameter. And then time, it describes time. Time unit. See, time representation can be in different form. All forms are supported here. And then table, the data is stored in column and rows. As we know, it follows record structure, so that table contains records. Records obviously stored in the form of rows and columns. Array also we are able to store data, but it follows one-dimensional table data with a specific size only. It is not dynamic one, it is a fixed one, specific size 10, 20, 30 data only we can store. URL also, if you want to link the XSIL document with any other document, that may be done by using this URL tag. And then any other URL reference can also be included here. Stream, for handling data streams, we are using streams tag. Sample XSIL file XML version 1.0 doc type XSIL. See here, doc type XSIL in the XSIL system XSIL.dtd. XSIL.dtd. See here, doc type, exclamation, doc type, and then XSIL prefix, system or public, and then DTD name. As I said previously, it uses its own DTD, so XSIL DTD, and then XSIL root tag. As I said previously, by using comment tag, you can include comments for the current program or current application. 5 measurements of voltage stored here. So parameters are gain. First parameter. Unit is millivolt and value is 1.453. And then the remaining values are stored in the array, one-dimensional array. The array size is, right, one-dimensional array. Array size is 5. And then stream. See, what is the use of stream? The stream used for handling data stream. We are going to store all data in streaming format, metallic format text, delimiter \n. I mean, all values are separated by \n. All values are given one by one. First value, second value, third value, fourth, fifth. Because the measurement of voltage, we are following 5 values, so that is stored here. Array is closed, and then XSIL is closed. If you want, you can refer this particular URL where we can get more information regarding the XSIL. And then next one, XML application in business and finance. There are several languages available in order to provide support for business as well as finance in the form of XML. First one, electronic business XML, EB-XML, used to integrate legacy system, which is nothing but very older system. See, in most of the business, older system may be running because some fear may be available in the some fear may be available for the business people. Those who are involved in the business, they won't, generally the business people won't switch over their business from old to new immediately. Gradually or incremental growth only, they are moving their business from old system to new system. So that it is EB-XML is used to integrate the business from old system to new system, and then it plays a major role in the financial transactions and used to develop the business applications, e-business applications. The examples are contract preparation, contract details comparison. See, in the contract system, I am taking the example for contract system. One contract is given to some of the contractors. In such case, it is not directly given to the specific contractor. Some process is involved in the contract giving process, so that first who is giving the contract, that organization gets a quotation from the advertisement, and then get the quotation from the contractor, and then compare the value quoted by each contractor, which one is less, that will be adopted, and so on. Lot of process involved in this process, so that the contract preparation, it provides a lot of tags. For comparing the contract details, it provides a lot of tags. It is an automated process. EB-XML provides an automated process, so that we are able to reduce the time required for manual computation. Computation that is entirely eliminated, fully automated process, so that the time is very much saved in the usage of EB-XML. It is a XML based language used in the business. And then FPML, financial products markup language. This is mainly used for financial applications, business financial applications. See, when you take the financial applications, it is not an independent entity. It is combined with some other sales, purchase like entity. It is combined with financial products are combined with see, business informations, exchange, the standard details between applications, or between phases of the application, or between modules of the applications, that will be dealt by FPML. And then the financial instruments are specified. Lot of financial cost and other category of accounts are available. In those category, financial instruments, specifically FPML focused on financial instrumentations. In that format, it stores the data, financial instrumentation specified format it is stored, and it is readable by both computers as well as human. So both readability is possible. In such a way FPML is created. It follows in such format. FPML is following such a portable format or common format, we can say. And then FPML enables the communication between system to system or business to business or business to application. All kinds of communication is possible in the FPML. And then the wholesale financial market can take the advantage of interactive technology to reduce the operational cost. Obviously, you know that manual intervention exists in a business. Definitely, some operational cost is there, as well as the wholesale business. Operational cost is very much needed in the wholesale business. That's why the wholesale business is taken here. So instead of using the traditional operational cost, we can make use of FPML and reduce the operational cost, because it provides system to system communication in an effective manner, as well as business to business and business to e-commerce applications, right? Business to business, business to consumer. All those kinds of communication is possible using FPML. And then the other finance related XML applications, XBRL, Extensible Business Reporting Language. It is also used in the financial application, and it describes to managing all financial information. And then financial information exchange, FIX protocol. The XML specification, FIX is an XML specification, as we have discussed so far. XML specification for the real-time electronic exchange of securities transactions. See, if you want to transfer any information in real time with the security, then you can make use of FIX protocol. And if you need interactive communication, see, we need to the interface may provide some interface provides some text box where we need to enter our bill amount, and by which mode you are going to pay the amount, either online or cash on delivery and so on. So this kind of payment mode, and when you are choosing card, credit card, debit card, and MasterCard, Visa card, see, there's different categories of cards available. If you are going for card payment or manual, cash on delivery payment, or nowadays UPI payment is supported, which kinds of payment is possible. So several interaction is needed in the financial transaction, right? Several interaction is required in the financial transaction. All kinds of interaction supported by IFX, XML specification for electronic bill payment, business to business payment, business to banking, and automated teller communication, teller machine communication, and consumer to business payments and consumer to business banking. See, lot of, in all applications, the human, interaction is needed. Interaction is needed. We give some information. Based on the given information, it executes certain task, and again it is asking some questions from the user. You have to give input for that, and so on. In such a way, the entire application is running. Why they are enabling this kind of interactive mode? If any problem in the financial transaction, in order to easily roll back of previously uncompleted transaction, in order to provide support for uncompleted transaction, they are mostly offering interactive financial exchange, interactive mode of communication in the financial transactions. And then market data definition language. As I said previously, data definition or metadata language is very important. By using this DDL, data definition language, we are able to define the vocabulary. Right? We are able to define vocabulary which will be used in the market. This may be difference between the locations. It may be different between locations. So based on the locations, we can create the vocabulary also. That is also possible. And then market data between, market data is exchanged between exchanges, vendors, distributors, subscribers, and so on. In order to facilitate this delivery of data between the financial entities or financial market, it increases the ease of processing for recipients of this market, right? It provides a better way than the other applications in order to deliver the data to elements of the financial transactions. and then metadata and archival applications. Metadata and archival applications. See, XML provides better way for maintaining metadata. This is the idle medium, right? XML is an idle medium for storing metadata as well as handling metadata, because XML is understandable by many different systems as well as different browser provide support for XML, so that XML is an idle medium for handling metadata, storing, retrieval, processing, and so on. And then the standoff markup is a different approach to represent the XML document structure, where the document structure is separated from the content. See, nowadays the content is separated from the structure. Nowadays, several programming languages provide support for MVC architecture, that you know, model view controller. Model view controller. See, what is the reason for using MVC architecture? Model database is separated from the application. Application core logic is separated from database and presentation. Presentation is separated from database and core logic. What is the reason for this? Easy management. Without affecting the other two elements, we are able to change the presentation. So in order to achieve that effect, most of the current programming language offers separation of content. Similarly, this standoff markup approach used for separating document structure from the content. If content changes, then only we will be changing the document structure. Without content change or without affecting the document structure, we can change the content and so on. Because of this flexibility, we are using this standoff markup. XML metadata can be embedded in the XML document. Obviously, the metadata is included in the XML document. Types of metadata. What are the types of metadata available? Annotations, cataloging and identification related information, subject indexes, and cross references. Annotation, which is nothing but notes. Annotation, which is nothing but slide notes which will be added to the document. Cataloging and identification, we can identify a particular part of the document. We can identify particular part of the document using some identifier, because metadata is associated with some property. Metadata is associated with some property or some elements and their values, so that because of this nature, the identification and the cataloging is very, very important. It is also called as resource based metadata. Based on the resource, we are creating metadata. Subject indexes, data which represents subjects. For what purpose, in what subject the data is created and documented. So based on the subjects only, data which represents subjects, and then different subjects can have interrelationship between them. All those things can be managed by using this type of metadata. Subject based metadata is used to the model and act as a properties of the information. And then cross reference, like annotations, this is also cross reference, is also very useful for long lived documents for a long period of time. If you are maintaining or if you are keeping for a long period of time for a specific documents, then those documents comes under cross references. We are able to maintain cross references in metadata also. It is also known as structural mapping, wherein the independents are mapped. Structural mapping, wherein the independencies are mapped. And then the other metadata language, schema adjuvants. It allows the elements to be used anywhere in the well-formed XML document. See, schema adjuvants provides lot of tags. By using those tags, we can organize our data, we can organize our metadata in a well-formed manner. Well-formed manner means the syntax is already defined for each and every place. The syntax is strictly to be followed, that is checked also, and so on. Several rules to be followed in the well-formed XML document, so that the schema adjuvant defines a lot of properties for the construction of well-formed XML document, and then it is used to create metadata and schema for the metadata, and that schema is validated during the XML data creation, XML document creation. And then resource based metadata. In the previous slide itself I told that based on the resources, right? It is not a global for all resources. Any structure or any schema, it is not global for all elements. The specific elements may follow specific schema, and that should be validated. So it is resource based metadata are validated during the schema definitions. The next metadata language, RDF, resource description framework. It is also a standard used to apply the description for the information resources. It has three object or entity type: resources, properties, and statements. Resources, everything called as resources. It may be whole document, part of the document, or any other objects like images or picture or animation, right? Anything available, accessible in the resource is called as resources in RDF. And then properties, what are the characteristics of the element or resources? Characteristics of resources called as properties, or attributes of the resources called as properties. Each property or collection of properties defined with a specific relationship, and also it is defined with the relationship with the other properties. And then statements, named property is called as statement. It is associated with the resource and its value. Another application, web and internet application. Already we have discussed several web and internet applications. Along with that, here web distributed authoring and versioning protocol, right? Web distributed authoring and versioning protocol. It is used to retrieve XML data. From Exchange 2000 server. From Exchange 2000 server, we are able to retrieve the content XML data. And then WebDev is an extension of HTTP protocol. We are able to easily attach with the HTTP protocol, and it is an extension of HTTP protocol, so that specifies how to perform file processing, making it easy to read and write to the web. And then it is, WebDev is based on XML encoding. It follows XML encoding format, and then comments that will be easily recognized by the internet and transferred to the server and get the response back from the server to client in an XML based. Let us say some example. In IE5, as a component called XML HTTP, it provides opportunity to use WebDev protocol for our web application. So we are easily able to retrieve XML content which is available in the server, that will be easily retrieved by using this extension. And actually the XML HTTP includes several syntax for opening connection with the server, and provides several tag support for exchanging information between client and server, check your status of your request and retrieve value from the server, and so on. All those things can be done by XML HTTP. So XML HTTP provides support for WebDev. See, a lot of XML HTTP methods list out in the table. Abort, current HTTP request can be aborted by using this method, and then get retrieve all header fields, right? Get all response headers. That is the name of the method. If you are using that method, it retrieve all header fields from the response message. See, request message and HTTP response message follows their own syntax. You can retrieve all those contents from the response message. Get response header. It retrieves the value available in the response header, and then open. It provides opening connection to the HTTP server, and set request header. It is used to set, because in the communication, before communication, several parameters are negotiated between sender and receiver. That should be negotiated and set one of the request header fields, and then send tag sends the request to an HTTP server that include a body. The body tag or body information can be retrieved by using that information that will be communicated with the other applications. So these are all the applications available in this unit. So you can study all of the materials. All the best for your exams. This is the last session. All the best for your exams. Thanks for listening. Thank you.